Hi everyone, this is a presentation by Group 2. This is myself, Dung Tran, and my partner.
Hi, I'm Golnoush Khosravi.
All right, so the presentation today focusing on the human joint. As you can see from the picture on the right here, these are the different joint in human body. So let's get started. So first, for our introduction, I want you to know the human joint are important. They're responsible for our movement. Those include the limb and stability. So how you classify the joint? You can classify them by their structure and their function. Um, so human joint, there's plenty of them, but there are three main type of joint that I want to cover. So the first one is the synaptosis. Those are immovable. So what happen is they are fixed. The two bone they close contact and they have no movement. They can also be known as the fiber joint. One example for the fiber joint of all the synaptosis is the bone of the human skull. The next one is the amphiotrosis. This one can be also known as the cartilage joint because they slightly movable, but they're not really freely movable. Just much better version than the synaptosis. The two bones are held together, but very tidal, so very little bit movement. So the example for that would be a human vertebrae or the spine. And finally is the diarthrosis. As you can see from the picture, those the position for the diarthrosis. Those can also known as the synovial joint, which means freely movable. So those joints have like a synovial fluid. They help them to the body part to move smoothly. So the example would be the knee and human shoulder. As you can see from the picture right here helps you see more closer. For our method, so how do we determine the degree of freedom and their range of motion? And well, the answer is you just estimate it. So what we do for our group is we just rotate our body to determine our degree of freedom, and we just estimate our value because we cannot know specific the answer. We just estimate. So when we rotate, we just look at our rotation, abduction, adduction. We elevate and depress our body structure. Like I say, human body is different, so we cannot tell specific number. What we do is we know that the range of motion are changing by the angle between their bone. So those include like flexion, extension, abduction, and adduction. So just in general, like flexion occur when the angle between the bone are decreasing. In compare, the extension is the angle between the bone are increasing, and vice versa. Abduction is when the bone move away from their midline body, and abduction is the opposite. The movement of bone is moved toward the midline of the body. So you can see from the picture right here how the bone movement, and you just estimate our value. Um, However, there's one way you kind of know estimate the value from it. So we found an article called Normal Range of Motion Hip, Knee, and Ankle Joint. Within that article, they also provide us the estimate value. So if you want to know more information about it, you can look for it. I already put the source over here. So based on the article, they mentioned like the total range for the motion of the hip joint is around 150 to 390 degree. The knee joint is about 115 to 170 degree, and the ankle joint is about 15 to 95 degree with respect to extension and flexion. For the result, I would like to introduce my partner to go over it.
All right, so for the results, we went over the motion range, different motion ranges of rotation and abduction, adduction, elevates, and depress for the hip joint. And it has the rotation of 90, abduction, adduction of 120, and elevate the press for 200 degree. And the hip joint has the total of 3 degree of freedom. The next joint is the knee, and the motion range rotation for knee is 0, and it has the abduction, adduction of 0, and the elevate and depress is 0 to 170. And the total number of degree of freedom for it is 6. The next joint is ankle joint, and the motion range for the rotation for ankle joint is 0, and it is 60 degree for abduction and adduction, and it's 90 degree for elevate and depress, and it has 2 degrees of freedom. The next joint is shoulder joint, and the rotation is 180 degree. Abduction, adduction is 200 degrees, and elevates and depress is 270 degrees. And the total number of degree of freedoms is 3 for the shoulder joint. Moreover, for the elbow joint, the rotation has a degree is 0 degrees, abduction and adduction has 0 degrees, and elevates and depress has 120 degrees, and the degree of freedom is 2 for this joint. And lastly, wrist has is another joint which has the rotation of 0 degrees, abduction and adduction of 60 degrees, and elevate and depress for 0 to 120 degrees altogether. And the degree of freedom for wrist is 3. Moreover, we move on to the discussion part, and based on the information we gathered, the human knee joint has 6 degrees of freedoms, and the hip joint is modeled as 3 rotational degrees of freedom. Furthermore, the shoulder joint is a ball and socket joint that allows 3 degrees of freedom. And the forelimb is 7 degree of freedom, while the hind limb is 6 degrees of freedom. Lastly, elbows have 2 degrees of freedom, and they allow to do flexion, extension, and pronation and supination. All right, thank you for watching our presentation, and this was the end of our presentation.